Great. Welcome back to another episode of Hard Math with Kevin. I'm here with our Chief Analytics Officer, Kevin Mabe, who is going to walk us through a time series analysis. If you've followed us before, you know that Kevin does a great job of setting up why these different analyses are important. So, Kevin, why would somebody want to do a time series analysis?
So time series are all around us, of course. There are some pitfalls with time series that must be taken into account to analyze properly. So the number one problem with time series is the fact of time, where things can be happening behind the scenes through the passage of time that may or may not be very evident up front. And so there has to be a few things taken into consideration, which we'll go through in this series of videos. When looking at time series. It's a bit different than, say, for instance, a cross-sectional analysis, for instance, like incomes by country, where it's just basically a snapshot. Time series tend to bring with it a whole host of its own issues.
Sure. Now, this might be a silly question, Kevin, but how many data points would you like to have, or how many different plots of time would you like to have if you want to do a proper time series analysis?
So that's a good question. So one thing that time series analysis does hold similar to other kinds of analysis is, the more data points, the better, because then you're allowed to understand the confidence intervals around the analysis and the statistics that you're calculating. Time also often has seasonality, such as week or month or quarter. And so I tend to like at least, at least three representations of each season, or a minimum of around 25, 30, 35 data points. So for instance, if I'm doing monthly metrics, I'd love, 3 years is a great place to start, although there are some conclusions you can make just off 2 years. If I'm doing quarterly data, 3 years only gives you 12 data points. Ideally, you would like more than that. So again, it's kind of that 25, 30, 35 minimum threshold to where you really are able to tease out a bit more what's going on.
Great. So walk me through what I'm looking at here. Obviously, plotting revenue across a series of time.
Yep.
So from a very basic sense here, it looks like it's going down, but
yeah,
help me understand a little bit better.
It's great. So we're going to take a look at, for this example, in the next few videos, total revenue, and this is actual real data. Just the variables are blinded. So total revenue, and then the revenue from product 1 and revenue from product 2, and there were other products in the bag. So what we want to discuss is, what are these time series doing? So time series often have some kind of trend, whether it's up or down, whether it's curved or not. They tend to have some kind of relationship within itself, whether that is a seasonality, such as it peaks in the summer and valleys in the winter, such as retail sales, or employment peaks in both the summer and the winter, but hits a bit of a nadir in the spring and fall, as well as just general movements across time. So what we see here for total revenue is, yes, Drew, it looks up to be a downward trend, and we'll talk about that. For product 1, it looks to be a bit of an upward trend, and then it falls back down. So maybe this is a U-shaped revenue, which is obviously not good for product 1. And product 2 looks to be a little bit all over the place, where it's going down, and then it's going up, and then it's going down again. So, one thing that's very helpful to understand about a time series is what is its underlying structure. Now, we're not going to go into a lot of the more advanced ways of looking at time series on this particular call, but what we will do is discuss what's called a trend break. So there's 3 general trend breaks that can occur, and what I mean by that is somewhere along this line for each one of these, there happened to be something that could have been different. And the question is it different, and is it statistically different? It could be a change in level, which means it was high and now it's low. It could be a change or shift in direction, where it was going up and now it's going down. Or it could be a change in volatility, where things were a little bit more stable and then they pretty much went out of whack. So what we're going to go through is we're going to go through this product. Actually, we're going to go through product 2. to see, was there a trend break in the past? And if so, where and what might be going on? Now, it's not going to pinpoint exactly what occurred, but it will statistically highlight if something occurred. So I'm going to run a quick little program here. Okay. So here's that same series, and now looking at it's running 3 tests. One is the level, or basically the means. One is a trend, and one is the variability. So Drew, what do you notice about this graph here?
Well, I would say the p-value jumps out. So
okay.
It would imply that whatever we're looking at is statistically significant.
Yep.
And the fact that I'm guessing those blue lines are the confidence intervals, the fact that they're not overlapping, to me would say that, we can say with some confidence that there is a change here.
Yes. So there's a couple things going on, and Drew, you nailed it all. Let me go into it just a little bit more. So what this program pointed out is back here, the revenue for product 2 was around 7.3, and then all of a sudden around observation 10, it shifted down to 7.15, approximately there. These blue bars are in fact the 95% confidence intervals around this mean, because again, because we only have so many data points, we can't be fully sure what this mean is, and so this is the confidence interval around it. And in this particular example, it does appear that they do not overlap, which means there is a statistically significant difference of the revenue from observation 11 onward compared to the past. The 0.003, it means it's pretty statistically significant compared to a 0.05 or 0.01 even. So let's go to the next test, which is essentially a change in direction. So this program also identified, and again, the confidence intervals aren't on this one, but it's behind the scenes around this p-value. This also highlighted a downward trend up until, a downward linear trend in this case, down until about observation 11, and then pretty much a straight trend from 11 onward. And that is statistically significant. And so, once again, we have some highlight that around this time period, something happened. We don't know what, but there's enough indication that something may have happened here.
Well, so that's really interesting, Kevin, because if you were to look at the first graph, you would say, wow, something happened, and now we're doing much worse.
Right.
That product's doing a lower revenue number. But in that second one, it would seem to imply that you've halted the downward trajectory.
Right.
Is that the correct understanding?
Yeah, that could be a very correct understanding. One can actually test how flat this curve really is, or this line is, and exactly conclude that since we know that this is a statistically significant difference between this downward trend and this flattening, that something has statistically leveled off. Now, we don't know from these data exactly what that might have been. It could have been an intervention, it could have been a coupon, it could have been, who knows, a whole host of things. But at least we're able to further pinpoint where this change may have occurred. Because if you take a look at the original time series, one can argue, oh, well, we perhaps did something in January and February of 2017, or, oh, we did something back here in 2015 because look how level it is compared to where it was. But, what trend to break analysis does is say, hey, let's take out the subjectivity and let's objectively take a look at this trend and find the most statistically significant break in the trend overall. And that's where these breaks are highlighted.
Right.
And the final one is variance one. And for this trend, it's not as important. This identified that the variability is most different if we break it at observation 8. And this test essentially says a p-value of 0.62, 0.84, depending on the test you use, which basically says that the variance is about the same across the board. So while there is the same volatility of the revenue for product 2, it appears that something happened around this time period where the decline was halted and then it leveled off, or it shifted from a high to a low. And then we can dive more deeply to figure out what happened in fall of 2016.
Excellent.
So the other,
cool.
yeah, please go ahead.
So go ahead. Sorry.
No, you please go ahead, Joe.
I was going to say, so we've analyzed this product, Now, where do we take that next? Where does this analysis go next?
So it's a good question. So, trend break analysis of the past is nice. However, here we are sitting in early 2019, and it's a bit too late to do something about 2016. Ideally, you would want some way to understand for incoming data, how can I understand how abnormally high or how abnormally low it might be? And just to give an example for this product 2, this appears to be a pretty low data point. The question is how low, is that abnormally low, or is it just kind of what I expect? And so the next video we're going to talk about is forecasting, kind of explain what forecasting is, and help give an example about how forecasting can be very powerful to understand what's going on.
Perfect. Great. Well, thanks as always, Kevin. That's helpful, and I'm looking forward to that forecasting video.
Thanks, Drew.